The work done to compress a gas is 74 joules. As a result, 26 joules of heat is given off to the surroundings. Calculate the change in energy of the gas. All right, so we know that the work done to compress the gas is 74 joules. And we are, we are looking for the change in energy of the gas. That's going to define what our system is. We always want to answer this question in terms of what the system is doing, not what the surroundings is doing. So when you read a problem, try to take a time to identify what it is that is the system, and then everything else would be the surroundings. And we want to answer this question in terms of the system. So the work done to compress the gas is 74 joules. That means that the system, the gas, has work done onto it. So therefore it's gaining work, and this should be a positive 74 joules. As a result, 26 joules of heat is given off. Heat is given off. That means that heat exits it, and so Q will be a negative 26 joules. We're looking at the total change in energy, which is delta U. Delta U is just delta E of a system. So it's really just another way of saying delta E, but we call it delta U because we are saying it's of the system rather than of the entire universe. So delta U is equal to Q plus W. So it's equal to negative 26 joules plus 74 joules, which comes out at 48 joules. Mathematically, this problem is very simple, but you may get it wrong if you did not get the sign right. So getting the sign right, a positive work and a negative heat, is really important to getting the answer to this problem right. Okay, let's try number 6. To inflate a balloon, you must do pressure volume work on the surroundings. If you inflate a balloon from 0.1 liters to 1.85 liters against an external pressure of 1 atm, how much work is done in joules? Okay, so we are looking at pressure volume work. The equation for pressure volume work is work equals negative P delta V. And the P in this particular problem always refers to the external pressure. That would be what the volume is expanding against. So the work is going to be equal to a negative 1.00 atm from the external pressure there. And then the change in volume is always the final volume minus the initial volume. So the final volume is 1.85 liters, and the initial volume was 0.100 liters. That gives us negative 1.75 atm liters. So this is almost the answer. But the question asked for the work in joules. So we need to convert from atm liters to joules. The conversion factor is 1 atm liter is 101.3 joules. So we'll take our negative 1.75 atm liters times 101.3 joules in 1 atm liter. And our final answer will be negative 177 joules. It should be negative because the balloon was expanding, which means it was doing work on the air around the outside of the balloon. The air around the outside of the balloon has to move And so the balloon inflating is doing that work. So this should be negative, meaning work is being released. All right, the last question on this video is going to be number 7. An expanding gas does 150 joules of work on its surroundings at a constant pressure of 1.101 atm. If the gas initially occupied 68 milliliters, what is the final volume of the gas? Okay, so again, whoops, sorry. All right, again, we are looking at pressure volume work. So this is going to use the equation work equals pressure times volume. And let's see what the equation gives us here. The problem gives us 150 joules of work. Pressure is 1.01 atm. And the gas started at 68 milliliters and it's going to end at, we don't know. That's what we're trying to find. All right, when we plug this all in, we're going to have to really think about what's going to happen with our units here. So work we have in joules. Pressure is going to be in atm, and right now volume is in milliliters. None of this is going to work out to make any sense unless we happen to remember from the problem above that 101.3 joules is equal to 1 atm times liters. So we can see right away that milliliters is going to be a problem, and we're going to need to convert this into liters. So there are 1,000 milliliters in 1 liter. That means that 68 milliliters is the same thing as 0.068 liters. And we're also going to need to convert joules to atm liters. Okay, so let's start with that. Let's convert our 150 joules into atm liters. There's 1 atm liter and 101.3 joules. This is going to give us 1.48 atm liters. Now we can plug everything into our equation. In this particular problem, the gas is expanding. That means it is doing the work. So work will actually be a negative 1.48 atm liter. And that will be equal to negative, the pressure is 1.01 atm. And VF is what we're trying to find. V initial is 0.068 liters. We can divide both sides by negative 1.01 atm. The atm will cancel, the negatives will cancel. On this side, that's going to cancel. And we are left with 1.46 liters equals VF minus 0.068 liters, which simplifies to 1.58 liters, or if we want to take it back to milliliters, 1,580 milliliters.